In this problem, I want to start with benzene and end up with this trisubstitute of benzene. And for this one, it poses kind of an interesting challenge where we have these three substituents, but nothing on these three positions. But one thing to kind of think about to guide us here is if we were to have an NH2 attached to the ring, that NH2 can direct chlorination ortho and pair it to itself. So if we had an NH2 there, we could put a chlorine here, here, and para. And then that NH2 could be converted ultimately to the Cl through a diazonium ion. But the problem is we don't want the chlorine at the bottom of the ring. So the strategy that we can use is to basically temporarily block that position. And we're going to block this as a nitro group. And then ultimately, we'll convert it to an NH2, then a diazonium ion, and then a hydrogen, effectively removing it. So it's a temporary blocking group. So in order to do that, let's actually start by putting a nitrogen at the top of the ring, and that will kind of kick off our reaction sequence. So our first two steps, let's do the nitration. And the reduction of the nitro. This gives us aniline. Now, we want to install our blocking nitro group. But this NH2 is an ortho-para director. So if I tried to do a nitration now, it would give me an ortho-nitro and a para-nitro as two products. So we're going to take advantage now of our bulky amide group. So let's install that. Now, this bulky amide group blocks the ortho positions, so that will allow us to nitrate at the para position. Right, now we are done with the bulky amide group, so let's go ahead and remove that. I'll add acid and water. Okay, now at this stage you have to be a little bit careful because you don't want to convert this nitro to an amine just yet, because if you ended up with two amines on the ring, everything you do with one would happen to the other, and you wouldn't be able to selectively do different things on each side. So at this stage, this is a good time to do the chlorination. Right, so normally we don't use or don't need a catalyst with a strong activating group like an amine on the ring. And I'm okay if you leave off the catalyst here. I'm going to kind of hedge my bets and put it in just because having this strong deactivator is going to slow the reaction down. So this is going to just help us out a bit. So we'll chlorinate the ortho positions. Okay, so now let's go ahead and take care of this NH2 on top before we deal with the nitro at the bottom. So that NH2 on top, we'll convert it to a diazonium ion. And then we want that ultimately to be a chlorine. So the diazonium chemistry we would use for that is copper chloride. So when we add copper chloride, here's what we end up with. So we have everything we want there. We have one thing we don't want, which is the nitro. So we need to get rid of that. Well, let's get rid of that through the diazonium ion chemistry. So I'm going to reduce the nitro to the amine with hydrogen and palladium. And then let's just go ahead and add our NaNO2, NHCl to convert that amine to the diazonium ion. And then finally, H3PO2 will replace that diazonium ion with a hydrogen, effectively removing it. And there's our final product.